So another application of electromagnets that we're all very familiar with is the loudspeaker, or just speaker. Now, if you've ever had a chance to pick up a speaker, perhaps a car stereo speaker or a home speaker, you'll notice that they feel quite heavy. And what makes a speaker heavy is a rather large permanent magnet which is attached to the base of the speaker. The permanent magnet is quite heavy. Now, if we look at the makeup of a speaker, we see that we have a specially shaped permanent magnet, okay, which has an electromagnet, okay, that is free to move in the magnetic field of the permanent magnet, and attached to that electromagnet is a paper cone. Let's take a look over here. I'll show you a simulation of the loudspeaker. Now, what you're looking at here is the shape of the permanent magnet. You'll notice that it really consists of two cylinders. That inner cylinder right here really represents the north pole of a magnet, whereas the outer cylinder, the larger cylinder, really is the south pole of the magnet, or vice versa. It doesn't matter. So we have this specially shaped magnet, and over one of the poles of the magnet, over that interior pole, what we do is we place our electromagnet, which is really nothing more than a coil of wire. Usually it's wrapped around a paper cylinder. Okay, here I'm going to use a slinky to represent the coil. I mean, it really is a coil. So here's the coil of wire placed over the pole, the north pole of that inner magnet. Now, you can imagine that when we put a current in our electromagnet here, in our slinky, it becomes a magnet with a north and south pole. For one direction of the current, okay, the electromagnet will be repelled by the permanent magnet and it'll move upwards. For current in the opposite direction, the electromagnet will be attracted to the permanent magnet and it will move downwards. So you can see that by varying the direction of the current, we can make this electromagnet move up and down. And if we attach a paper cone to this electromagnet, as the electromagnet moves up and down, it will then push the air and create a sound wave or pressure wave. Now, a time-varying current can have a pattern to it. Maybe the pattern of that time-varying current matches your favorite song. So we can make this electromagnet move down in accordance with that pattern and cause the air to move in a very periodic way that also matches the pattern to recreate the sound wave. So let me take you over here and we'll show you a functioning loudspeaker. Now this one is a dissectable one, so we can see the parts a little better. You'll notice here at the base is the very large permanent magnet. Of course, the inner pole is hidden. And if you can see through the plexiglass wall here, there's an electromagnet which is free to slide up and down in the magnetic field of the permanent magnet. Now I'm going to use this signal generator over here to provide an alternating current. Okay, and we'll increase the amplitude a bit, and you'll hear a high frequency sound here as that electromagnet is moving up and down. Now I haven't attached a paper cone here, but I have attached a wire loop, and we can check out the motion of the loop. Let's lower the frequency of this current here, this alternating current, and you'll be able to hear the sound wave create a change in pitch and frequency a little bit. Okay, and at a low enough frequency, you'll be able to see the motion of that wire loop. Okay, so right around here we can start to see that loop move. That loop begins to move as the electromagnet is moving up and down. Now this is at about 100 hertz, so this is still quite fast. If I bring it down to a low enough frequency so our eyes can actually detect the motion, okay, somewhere right about here you will just about start to see that electromagnet, the individual up and down motions of it. Okay, and here it's creating a sound wave that's very low in frequency. It's very hard to hear. Okay, but you can see its effect on the wire loop. You can tell that electromagnet is moving up and down in the magnetic field of the permanent magnet. If I bring it down even lower, at some point you'll be able to see the electromagnet moving up and down. Now it's about 15 times a second. Your eye can easily see it move up and down. So you see here one more application of electromagnets, that of the loudspeaker.